almost ready, as I said. You go to solver. There are a number of things that we have to define here. Each of these boxes, there is something that we have to define. Set objective should refer to the cell that contains your objective function value. So simply click on the objective function. You can maximize, minimize, or set the value of your objective function to a certain value. In this case, you want to maximize. Sometimes you want to minimize the change. This one. By changing cells means defining your decision variable, referring to the guess values of your decision variable. So I just click them. Select them together. Okay? And the constraints. You need to add them one at a time. You can add them, change them, delete them, and reset them. You can do a lot of things here. But initially, of course, you want to add them. Once you push the add, this box, this window pops up. There are three things that you have to define for each constraint. The left-hand side, the right-hand side, and the direction of the constraint. Right? So this is the box for left-hand side. I can say, okay, this is my left-hand side for the first constraint. This is my right-hand side. And the direction, by default, is always less than or equal to. You can always, if you think it's necessary, change it to equality or greater than or equal to. You can say int, which means integer. If you want to define something as integer. You can define bin, which means binary. If something, some decision variable is 0, 1, decision variable. Or arc. So here, for arc initial case, we only have less than or equal to, so we just do not change it. Okay? And then add. And add one more time here. Less than or equal to the right hand side. And then add. Now, if I go back by pushing cancel, if you go back to the previous window, these two constraints are the ones that you define. Right? This is a kind of inefficient way of defining the constraint because I'm defining one at a time. Sometimes you can define collectively, right? And then save time. Let me just erase these two and then show you how you can define the two constraints collectively. If I go to add again, on the left-hand side. Now, since I know that both of these two constraints are less than or equal to, I can collectively define them by taking their left-hand side at the same time and their right-hand side at the same time too. So here, I can say these two must be less than or equal to these two because I know both of them have the same direction. And then add. We also have some sign constraints. We must make sure that our decision variables are non-negative and they are integer. Alright? So you can say decision variable means the guess value. You take these two collectively and then say greater than or equal to, you can just put 0 here, takes care of everything. And add. And again, take them. And in the middle one, say int, which means integer. Alright? Because you cannot produce 1.2 chairs. So we are done. You have some options for solver. What kind of solver you want to use? Simple Excel is probably the best one to use, right? Because you already know that this is linear program. Sometimes you need to change some options here. Let's try to solve the problem. This looks like, I will show you later on what each of these options mean. As we go through the course, we will have to discuss the details of simplex method, and I will basically let you know what we mean by each of these. So, But here, let me just change this to lower number, and the optimality. And okay. And just push solve. It should solve for you. In a fraction of a second, it will find the optimal solution for you. And these are the optimal solutions: 24 chairs and 8 tables. And you gain 1360. Well, is this the same solution as you got for based on graphical method? I'm not sure if you found the solution based on graphical method to the end. But if you find the cross point of the two major constraints of the problem, you will get that 24 and 8. It basically means that there is no other way of achieving a better profit than producing 24 chairs and 8 tables. Right? This is the maximum that you can gain, 1360. This basically means if I change this order, 20 and 5, I'm not going to gain as much as I want. Right? So 28 and, what is it? 24 was the best way to go. I'm using up this 40 and 120 that turned out to be equal to their right-hand side are telling me that I'm using up the entire resources that I have. Sometimes using up the entire resource that you have is not the best way to maximize your profit or optimize your objective in general. Sometimes leaving out a portion of your resource untouched might be the best idea, might give you the best possible optimal solution. So it's not always the case that we have to use up the entire resources that we have in order to achieve our goal as much as possible, right? This just turned out to be the case that the best way to go is to use up the entire resources. Questions? All right, let me show you one more time how